Hello guys, today we're gonna start with lecture 14, considering that lecture 13 was showing you how to configure Masm and TextPad. That's really good. That's another alternative for using visual, and hopefully from now on we're gonna start the programming part, let's say the fun part. Now, going back to the system organization, what we took previously, the 12 chapters, I tried to minimize them as much as I can, or the 12 lectures, let's say. They're really important. Knowing the hardware of any machine is really important to knowing assembly language. I don't think you can do it without knowing the hardware. So please, guys, remember, assembly is near what? The hardware. It's the last thing before the hardware. So we need to know. Assembly is going to be communicating with the hardware. So you need to know the hardware. The system organization we had, remember, we had a processor, a CPU. Each processor or each CPU has an instruction set architecture. ISA, instruction set architecture, and usually I say that I declare it this way. Think of it as the vocab of the processor. It's the instruction that a processor recognizes. Each processor has a number of instructions that it can recognize, and if we have two RISC and CISC, two architectures. RISC is the reduced instruction set architecture, processes that come with a reduced amount of instructions. That will give us speed. Let's say speed, less memory when you have less instructions, but it makes programming more complicated. We have then the CISC and RISC. CISC is the complex set architecture, where we have a larger number of instructions for the processor. Makes it easier to program, but makes it slower, and there's more differences between them. I don't want to go into it now, but that's mainly what's instruction set architecture, and that's what we need to learn programming. I need to learn what does the processor know, instructions. What instructions does it know? Why do I need to know the instructions? What's a program in C, C++, Java? A program is a set of instructions translated to what? Assembly to machine language. Instructions to what? To the processor. That's what's a program. It's instructions for the processor. If you don't know the processor, you're not going to be able to program in low-level language. Usually in C, remember, C is high-level. Lots of abstraction is hidden or user-friendly. You don't know that much what's happening in the back. We talked about registers a lot, and I'm going to keep going over them. What's a register? It's a memory. And remember the memory hierarchy. Registers are on the processor. Anything that the processor needs to process needs to go through the registers. Fastest memory. It's a memory that's on the CPU. It's the fastest memory. Remember, we had registers, we had cache, we had physical memory, or RAM, let's say, and then we had hard disk. And we're going to be focusing on the Ia32 instructions or architecture, which is the x86. And what we mean by the x86, well, they have the X is 8086, 801, 86, 802, 86. All those are Intel processors. Intel processor, a family of Intel processors, and you can go read the history about it. The x86 family, let's say. Why learn assembly? I think, and I heard it from a guy, and I honestly believe it, but I don't like to say it. Assembly programmers don't think that C++ guys are programmers. This is what they think about. Though there's lots of people that are computer scientists and programmers, they don't know anything about assembly. and that's really bad. You're gonna see how learning assembly is gonna change the way you look to programs. It took me about let's say a year and a half. Assembly is a little bit hard. It took me about a year and a half to know it really good, and I don't think I'm really good in it though. But I try to learn more than one language. I try to go in so much detail about it. I was enjoying, and honestly I prefer assembly more than C++. Though you might think that's crazy, people think assembly is much harder, but I don't know. I like assembly more than C++. So another thing is hacking. In security, assembly is really important when you go, and lots of people don't realize that, and I didn't explain it before, but think of there's string matching, buffer overflow. All those are done in assembly. There's the code hacking. When you get a binary, I explained that one. When you get a binary code, convert it to object, get the, at least when you look at the code, if you know assembly, you'll be able to figure it out. But if you don't know any assembly, it's not gonna mean nothing to you, and it's hard to get it back to C, C++, or Java. It's not that easy, so it's can, but we can get it back to at least object code where we can get something from it. While an assembly also makes your high-level language programming much more better. And this depends on you. What do you want to be? Why did you study computer science? Do you want to be a good programmer? Do you want to be a good in security? Do you want to be in anything? You're going to see how routers, networking. We're going to talk about MIPS simulator, which is another programming language for the ARMS processors. Now they're taking everything in routers and gateways. So it's really important. If you want to be unique in your major, I highly recommend to spend time on it. This what I'm giving you is not enough. You need to do lots of reading for assembly. Lots of reading. Remember that. Okay, need to know the differences between those. An instruction. We said an instruction, for example, a move, add, sub, divide. Those are instructions. Directives. What's a directive? A directive, it's like an instruction, but it's not a part of the instruction set architecture. But the processor can recognize it and acts upon that. Some of the directives that we're gonna have the .data, .code. We're gonna know what those means, but mainly those. I don't think you're gonna get it now. But when we go into coding and I tell you this is a directive, this is a micro, this is a procedure, you're gonna get it. But you need to also know the definition of them. Macros, same as I like to explain it this way. It's a text substitution. Substitute text wherever you have a part of program. Same in C. Why did we use functions? Code reusing. Classes, code reusing. Macros are the same, where we, instead of repeating the code, anything you think you can need later, you can do it as a macro, and we're gonna see how to do those. And basically the Irvine library is all macros. This is what Irvine went and did. He came and took the assembly language and did macros on them, making the CN process, like to input characters easier, to output characters. He did them in macros. He made assembly more high-level language, more near to C++. That's why I consider now I'm gonna be talking about high-level assembly and low-level assembly. And wherever I have micros and procedures, this is high-level languages, high-level assembly, let's say. and we're gonna take the low-level assembly. And this is I think starting with the high-level language, high-level assembly, and going down to the low-level is really good. And you know more later. Procedure. What's procedures? Procedures are functions, but in assembly they call them procedures. That's the only difference. System calls. System calls are really important, and most people don't know what's. Have you heard APIs? Application Programmable Interface. It's the let's say any hardware you do, we need to access it. We need let's say functions, similar to functions, system calls to access that hardware, to tell it do this, do that, do not the instruction, not a CPU processor, hardware. Now we're talking. So to access, for example, to access the operating system, Windows, Unix, Linux, we need system calls. How do we do the BIOS, the C and C out? Those are standard input, standard output. We do system calls. It's a lot. You'll take those in let's say operating systems, when you do processors, where you do inter process communication for Unix, Linux, shared memory in Windows. If you heard about sockets, networking, fork, how to create a new process, all those are considered system calls. And what a system call is, it's basically, now when you're programming, who's in control? The programmer. Let's say you want something from the operating system. Remember, when you go from integer main, control transfers from the programmer to the from the operating system, sorry, to the programmer. Now, if you need something from the operating system, what do? We call it by a system call. Oh, open a file, create a file, system out, system in, any of those, interrupts. All those are considered as system call, where control transfers that from the programmer to the operating system. You need something from the operating system, you're going to do a system call. Call the operating system. Call the operating system. This is the easiest. Interrupts are the same as system calls, but usually they happen not in our hand. It's not. We don't need to have them. Interrupts when something goes wrong. Interrupt. Notify the operating system or the CPU. Something went wrong. Hey, I have a number over 0 value, undefined value. Now we need the operating system to deal with it, or the processor. So that's an interrupt, where also control transfers from you. And usually interrupts, meaning what? Meaning system calls are going to go in a queue and they'll wait, and but sequential. Interrupts, no, you have to. Operating system has to deal with it. Leave everything in your hand and deal with this interrupt. Assembly language. Now this is the problem with assembly, and why lots of people get frustrated, especially who are taking the Irvine. But don't be, because you take the Irvine and you go look online and you try to find any code. Like if you go to Java, C++ and try to look for code, you'll find lots of code, lots of explanations. In assembly, you're gonna find so many different explanations, so many different languages, so many different instructions. Why is that? What is it based on? What is it based on? It's based on the processor's instruction set. And each processor, each family, Intel, AMD, ARMS, all those have different instruction set. And assembly is the instruction set. Why we don't have it in C, C++, Java? C++, Java, they're standard. They have a standard SAMX, and the compiler is responsible for translating it to the desired assembly language, or the assembly language that suits the hardware that it's running on. And remember we said high-level languages are portable. C might be half-half. We can go discuss about that, but I don't want to argue about it. But assembly is not portable. Assembly is not portable. We have so many different assembly languages, and you're going to be shocked now if you see how much we have. And I was trying to go fast, but it's important for me in the beginning to understand everything, you guys. So, assembly languages. I should have said comparison between assembly languages. Sorry, let's see, it doesn't have it here. Comparison of assemblers, let's see. Okay, look at those assemblers, and those take different languages. Some of them look genuine, those we can, they're not free. We have those that X80, it's some of them are the first time I've seen their name, and even if you tell me, I won't know. It's an ARM assembler I've heard of, and this is what we're going to take one of them, which is the MIPS architecture, and it's really good for education purposes. It's totally different. You're going to see the difference between it and a Masm, which is, here's the Masm, Windows DOS, and operating system 2. We can see what FASM is a really good one. FASM, SASM is another really good one. Usually I think what comes with the C compiler is GAS, but those are for what? The X86, remember the family, the Intel family mostly. We have the there's two syntax, the AT&T and the, I forgot what do they call the other one. But look how much assembly languages they have. We're going to take Masm, two of them, two different Masms we have. I'm going to show you. We're going to take Nasm, TASM, which is now not used, but it's similar. There's lots of similarity between it and between Masm, so I'm going to go over it real quick. At least you know about it when somebody. JWASM is the same as Masm. It's a good replacement for Masm. So I think when you go and know more of those, the more powerful you get in assembly. It made lots of difference when I each language I learn more. It makes a big difference. See, look how many assembly languages we have. Not like C and C++. Let's go back here. Come on. No, I don't want to start from. I was trying to do the F5, Shift and F5, it didn't work. So, sorry. So many different assemblers and assembly language. Not like C, C++, and Java. Not like if you know C, it's not gonna differ if you use another compiler. The difference is not that noticeable, let's say. Different assemblers use different syntax. Let's say accents. And Each one comes with a different dialog. Some assemblers exist only for a particular operating system, and that's true. Some of them are for Windows, some of them for Unix, some of them are for more than one, but it's gonna be complicated to configure it. Why? Think of it. We were talking about system calls. Windows system calls is totally different than Linux system calls. I think in Windows, what do they call them? Win functions or something, but there's the Windows does it in 2 passes, and they have subsystems also, and Unix is also totally different. So that makes a big deal, but we're gonna see when we take Masm we're gonna take is for Unix based. And Masm, I'm gonna show you, I'll try to show you similarities and differences between them so we can get a hang of it more. Some are high level and some are low level. For example, Masm, where we use the Kip Irvine library, this is high level. Masm 32 has another library where it makes stuff easier. And let's see now. We are going to cover the Masm 615. This is for the Microsoft microassembler, let's say. Microassembler. With Kip Irvine. Windows came out with this assembler, but now they stopped selling it. They only include it in the Visual Studio. It comes with the Visual Studio. But if you download, but then came Masm 32, and they did a library, and they used the similar, let's say, assembler, or the same assembler, but they did some changes. So we're gonna take both of those. I'm gonna start with Kip Irvine for like basically the first 20 programs, let's say 15 programs. Then we're gonna start going. I'm gonna give at the beginning also a couple of the others program. Each time I feel that we need any of the others, I will include it, and I'll tell you why in the first program. You can see how much difference between them. We're gonna do both of them without libraries, so we're gonna go from high Masm to low Masm. That's really good. And we're gonna do Masm, also high and low. Masm comes with a library similar to the Kip Irvine, and it's from him, along 32. It's another library that we can use, but we're gonna do it with a library and without a library. And we're gonna do the MIPS, or assembly language. We're gonna use the Mars simulator. It's an online simulator. This is really good for education purposes, and it's a lot different from those, but it makes assembly language fit more, and you'll understand it more, let's say, what's going on when you see different approaches for each problem. Now this is another really important thing: types of operands. Types of operands are really important to know. We have, they consider them 4, but I consider them 3. You can consider them as 3. We have registers. We took, how many registers did we have? We had 8. I'm gonna go over them in a minute. So memory, a memory location, num1, total size. When you declare integer num1, what's those? Those are memory location labels. This is a type of an operand. And what do we mean the types of operand? Operand of an operation. Let's say I have A plus B. A and B are operands. Where's the mouse? We haven't used the mouse. A plus, and let's say AX. A is a memory location. AX is what? Is a register, and let's say -5. And 5 is a constant and if I say 5 multiplied by multiplied by 10, 5 multiplied by 10, that's a constant expression. So those are memory locations, those are registers, which is also memory, but those are on the CPU fast. Constants, really easy to know. Constant expression where I have two constants, or sometimes they call this, in other books they call both of those as immediate values. And it's really important to know the types of operands, because when I say move num1 and num2, I can't do a move with two memory locations. I can't do as operands. I can't. It's gonna give me an error. Where operands have to have size, match in size. All that we're gonna take it. You're gonna see why it's important. Registers. Remember, we had 8 general purpose registers, which are 32 bits: EAX, EBX, ECX, EDX. Those are the main 4 that we can divide into 8, 16, and 32 bits. Why we can divide them? So I can use what? This is a byte. If I want to use a byte, I'll use AL. If I want to use a word or 2 bytes, those two, I'll use what? AX. And if I want to use the whole 4 bytes of the register, I will use EAX, because we have 8-bit operations, we have 16-bit operations, and we have 32-bit operations. And now we have registers which are 64-bit. We have another 4 registers, which is SI, source index, destination index, and E is for extended, because first we had 16-bit machines, 8-bit machines, 16-bit machines, extended. We have EBI, base pointer, and stack pointer. Base pointer, stack pointer, those are used together on the stack. Those we can use with arrays, strings, and we're going to see how we can use them. And usually we can use, if we're not using them for an array or a stack, we can use them as general, and we can use them for anything. We have 2 dedicated 32-bit registers. Those are really important. We have the E flag, which holds flags. Flag is 1 bit, and if you remember, I explained those as parity flags, carry flags, overflow flags, sign flags. If I had an addition operation and the result was 0, think of interrupts. I'm gonna change the 0 flag to 1, set it to 1, telling the CPU I have a result. Be careful, I have a result, that is 1. I'm not doing anything, I'm just telling the CPU. Whatever the CPU, the way it's programmed, the way it's built, how it wants to deal with it, it will deal with it. But we tell it, I have a 0 value, I have a carry, parity, I have a negative value, overflow. We will go over some of those flags. EIP, this is the most. Extended instruction pointer. It holds the the address of the next instructions to be executed. Why do we have it? Makes it faster. If the CPU has the address of the next instructions on a register, instead of going grabbing it from memory, remember the fetch instruction, decode, fetch operand, execute, and write back, instruction life cycle. Now see how it all fits together. And honestly, if you don't know most of this, you're gonna get lost. Like, why do I need the EIP? Why is it important? Why do I have a register that is designated only for the address of the next instruction? Makes it much faster. Immediately when we go fetch this instruction, EIP is incremented to the next instruction. We have 6 segment registers, which are 16-bit. And why is it 16-bit? It's because the addresses, and those are gonna hold. This is the code segment, the address of the code where it is, data segment where the data is stack segment, and extra segment. Those four we're gonna see them in in most of the programs, let's say, and those are extra, GS and FS. Honestly, I've never used them, and I don't think you need to know them. If I went over anything that I think it's useful, I'll bring them up again. Now let's go to the Ia32 instructions, which we're gonna be programming. x86 architectures, we're gonna use those assemblers. An instruction, DEC, assembly, mnemonics. I'm using symbols. Decrement, register. Minus minus, register is like saying register in C++. Minus minus, decrement it. If the register had 10, now it's 9. I subtract 1. I subtract 1, and how does it takes either a register or a memory. Don't think it takes one operand. A decrement instruction takes one operand, either a memory location or a register. A constant it doesn't take. I can say decrement 5. Decreases the value of operand by, sorry, that's increment and decrement. And I don't have increment. INC is the increment. Sorry about that, guys. Decreases, I think it was the first one, and then it went. This is decrement, and both of them take what? One operand, either a register. See why I told you it's really important to know what type of operand. You don't want to be programming wrong instruction, getting errors, and then negate, given a negative value for a number, either a register or a memory location. Negates the operand and stores the result in the operand, in the same operand. Like, let's say I have an EAX5, EAX equals 5, and I do the negate. Now EAX will equal -5. And not the bitwise logical not. Bitwise. Remember, I always said when we what's a CPU, we say arithmetic and logic unit, responsible about doing arithmetic and bitwise operation. This is a bitwise operation, taking the if you remember when we took the Boolean algebra, it's the comment or the not gate. The not gate. If I had 1 0 1 0, what's the not of it? All of it. It's going to be 1 0, like the one's complement. But usually it takes 1 bit. So if I take 1 bit, 1 is 0, negate, and 0 is 1. I have the move instruction. It moves, and here's how this assembly goes. From this is the source to destination. Don't think source to destination. There's some assembly language. MIPS is that way. That's why I want to introduce MIPS also. MIPS goes the reverse way. We can have this one as well. Here's the two operands. This is it the source or destination? This is the destination. Let's say D, and this is the source. And it goes from this to this. So I can have my destination as a register or memory location, EAX num1 whatever I want, but I can't have it a constant. So I can't say move. See why you need to know lots of details in assembly. I can't. This is gonna give me an error. I can't move a register to a constant. Because what? 5 is not saved any place. It's just an immediate value. So when I move the register to it, where is it going to be saved? It's not saved. If I save it, it's a memory location or a register. We have the compare. Compare this with this. Is it equal, less than, greater than? And we'll see, depending, every compare comes after it comes a jump or loop. A jump, depending, jump not equal, jump equal, jump 0, jump to another address or location. We have the LEA, load effective address. Load effective address from a label, and we're gonna see what's that. Load the, it's like using the offset. Load the address of this location, put it in a register. Add, I'm adding this operand with this operand, and I'm saving the result in this operand. So if I say add, and I can have the first operand as a register or a memory location, and let's put it as AX. AX what? Is a 16-bit. I didn't use EAX. And plus 10. This equals what? I'm saying AX equals AX plus 10. Add 10 to AX and save it in AX. This is the add. Sub, same thing, and we're gonna cover both of those. Mul, we're gonna be careful about the mul and div and those other instructions, and I'm just putting them now here. I'm gonna go into them in detail later. Those take one operand. So think of it, how does a mul operation takes one operand? It takes whatever is here, multiply it with whatever is in the accumulator. So whatever I have as a register or memory, let's say I have EBX. So EBX multiplied by AAX. Same thing in the division. We're going to go over those in detail in later, but let's try to cover. I'm going to try to go over examples over all of those instructions in Masm Irvine. And if you saw last video 13, which is lecture 13, it explains how we can download the Masm, the one for the Visual Studio, without Visual Studio, and make it work with the text pad. You can go check it, or you can download Visual Studio and use that one, but it might give you a hard time. Let me show you. Let me explain. I don't want to go. Try to download it and be careful. Really careful the instructions. Go with every instruction in detail. Don't just go over it and leave it. Okay. All of them are downloads. Where am I gonna find them? Okay. Here's getting started, and if you want to go, if you downloaded 15 or 17 Visual Studio, go to the 15 one. Go with those instructions carefully. till the end. And I had lots of students that had a hard time to do it. The problem is, some of you will skip some, and so they don't understand, they just skip it. If you skip it, that's it. It's not gonna run the program. This is configuring what? Masm or the Irvine library with the Visual Studio. You need to go in each step of those. But I think if you have any hard time with this, go do the TextPad, the video I did. It's much easier. But it's really nice. I worked on it in Visual Studio. The problem in mine is, I don't know, I've been trying to download Visual Studio. I haven't been using Windows for 7-8 years. And I got Windows a couple of days ago just for you guys. Or let's say 2 weeks ago, just to try and install Visual Studio and show you on Visual Studio, but it keeps giving me error. That's why I hate Windows. But anyway, this is what we're going to be programming. Does he have it on TextPad? He doesn't explain it on TextPad. This he explains it here for I think the Masm library. Go check it, download it. If you have any problems, I still remember how to use the Visual Studio, and I'm still familiar with most of the errors. If you have any problem in downloading it, and just put the error in a comment and put it on this video, and I'll try to get back to you as soon as possible to see what's the problem. But try to get it running before you get to classes. Masm instructions, let's see, this is going to go over the move instruction, and I explained it. Move from source to destination. The second operand is the source. This is saying destination equals source. We have some rules for this. No more than one memory operand permitted. So I can't have this as a memory operand and this as a memory operand. I can have, for example, this as a register. This is the memory operand. Memory operand, register. I can have this as a memory operand and this as a constant. But I can't have this as a constant. We're going to see a restriction on that. This is move num1, num2. This is not valid. We cannot, CS, EIP, IP cannot be destinations. I can't say move CS something. I can't do that. EIP num. Why? Remember, what did we say about EIP? It holds the instruction, the address of the next instruction to be executed. So if we allow it to change the value of that register, it might screw the flow of the program. So those are by default. This is going to give you an error. We can't move to those registers. If we want to move, there's a way for that. Destination cannot be a constant. It can't be a constant. Makes sense. If I'm moving source, where is it going to save it? The constant is not. It's not a memory location or register. It's an immediate value. Immediate value 10. No place for it in memory. No immediate to segment. Same thing. I can't move to segment register. CS, ES. We don't want to change the flow. Remember, the code segment holds the address of the code segment. Data segment holds the address of the data segment, code segment, stack segment. Stack holds the address of the stack, where the stack is. And every program, usually, this is what happens. Let me show you. I can talk a lot about the hardware. And why do I know a lot? I don't think that, but I took the computer architecture class. Advanced and a regular class, so I think this is every program. This is the memory of every program. This is the code segment, stack segment, and this is the data segment. What was the third one? No, the GSFS, ES. One. This is the extra, extra segment. Those are, so here stack segment, we're gonna need the address saying here it starts. Code segment, we're gonna need say here it starts. Data segment, here it starts. So every program is divided into those 4 segments. A size mismatch, we have to have them operands same size. So I need to have I need to move a byte to a byte. I can't move a byte to 2 bytes. I can't move 2 bytes to 1 byte. Meaning if I'm using EBX, I can't use with it AX. EBX is 4 bytes, AX is 2 bytes. That's why I told you need to know the registers also. See, anything small you don't know can cause errors, and it's gonna be hard to figure it out. This is not allowed. It's gonna give you an error. If I had a memory location, how is it gonna figure if it's an error or not? Usually we're gonna define this either as an integer. If it's an integer, what's an integer? It's a 4 byte. So this is allowable. If I said a short is 2 bytes. That's the way how it depends on how we declare the memory locations, and I'm gonna go over the declarations and when we take the examples on them. I think that's a better way. So how many rows for the move instruction? 5. See why I told you have to do lots of reading in assembly? We have to know this. Not just knowing the move instruction. No, I have to know no more than 1 memory operand. I can't move to this. I can't have destination as. And I think most of them make sense if you try to understand it. Size mismatch. Masm instructions. We have also the move 0 extended. This is where I try where we have BL is how many bytes. See now where it comes. Do you know what's BL? BL is part of the EBX. The 8. Remember? It's gonna be slide 16, chapter 2 in your slides when you take it next semester. That's the most important slide. Explains the registers. You need to know it really good. Start with it now. I can divide this to what? Below. This is 4 bytes, yeah? Below 1 byte. B high 2nd byte, and EBX the 4 byte, and I can say BX as BL, or sorry, B high, this is H, and I can say BX as both of those as 2 bytes. 1 byte, 1 byte, 2 bytes, 4 bytes. I can break down my registers into smaller bytes. Move 0 extended is gonna move what? Whatever is in BL, I'm moving 1 byte to 2 bytes with 0 extended. So whatever is in BL, let's say 5, it's gonna have, so now AX is what? It's 2 bytes. It has AL, A low, and A high. And this is what's gonna happen. And I'm gonna try always, knowing the memory, how to draw the memory helps a lot. I'm gonna draw the memory of every program. A high. So if I had in BL 5, it's gonna put a 5, and what do we use? 0 extended. It's gonna add how many zeros here? This is 1 byte A8. It's gonna add 8 zeros. This is the 0 extended. Now if I go to the sign extended, it's gonna go look at the last bit here, or last bit in AX. If I'm doing AX to EBX, if I'm doing 2 bytes to 4 bytes, it's gonna look at the last bit, the sign. We call it the sign bit. If it's a 0, it's gonna extend it with 0. If it's 1, it's gonna extend it with 1s. This is the move sign extended, move 0 extended. There's only one rule for this: destination must be a register. If I want to extend, I have to extend to a register. We have the exchange operand 1, operand 2. We're doing exchange. We're doing like, it's like saying move EAX to temporary, then move EBX to EAX, then move temporary back to EBX. This is the exchange command, so we don't lose one of those values. And actually you can do it in 3 moves. At least one operand must be a register. This is one of the conditions. Same size, they have to be the same size. I can't have an immediate value register. Why? Because at the end I'm gonna have a move, and the constant or the immediate is gonna, let's say 5, it's gonna be the destination. And remember, I can't have that as a destination. A constant or immediate is a constant value, 5, 10, 20, 100. I can't have it as a destination. And how does it go in assembly? This is the destination and this is the source. This is at Masm. Add, we're doing destination source, add AX20. I'm doing what? AX equals AX plus 20. It's going to add 20 to whatever value I have in AX and save it in AX. Sub, same thing. Increment and decrement, here's both of those we took examples on. And we can have it as a memory location. This is a memory location. Or as a register. Types of operands. I'm going to keep going over them so you can remember them. So I'm gonna naggle a lot about them at the beginning. I was gonna go now and show you how to run the first program, but should I go do it? Let's do it. I didn't want the video to take that much time, but okay. We're gonna run our first assembly program. Remember, you need to set what? The Masm 615. Go to the previous lecture 13. But remember, you're gonna have I think a headache with the, but it's good. Visual Studio is so much user friendly. I prefer using the command line, and we can do it on the command line, but I don't want to confuse you now. We're gonna get to that one soon. Now remember, guys, please read, try, don't. At the beginning it's hard, but you'll know it because there's lots of details in it. Come on. Okay. What did it wrong? I already have the textpad set with the Irvine library. You see, I don't use Windows that much. I only have okay, blah blah blah. I need to go to open. I'm gonna have it on my C drive. This is really important. You're gonna have it on your C drive also. We're gonna do Masm 615. examples. Remember, you're not gonna see examples now until you set up your environment, and it's not that hard to set it up. Let's go to chapter 3, and let's take the template. I should have shown you how it looks like. This is title, program title template, and this just put in the title. And usually if you take the title out, it's not a problem. I don't want a title. In assembly, comments are by what? Semicolon. So this is a comment. Remember when we used in C++ forward slash, double forward slash, or forward slash with star? Those are comments, so we don't need those here. Now we're including the Irvine32 library. This is, we need it. Insert simple definitions here. I don't want this for now. I'm not gonna have any definitions for this data, but here's how I want to show you how a program should look like template. And let's take this out. Exit, I need the exit. I'm just trying to take the extra stuff so you can see in exactly what is. Remember we had what? Include std maybe in C, IOStream in C++. Then we had what? Integer main, or using namespace, integer main, my function. Here we have data segment. That's why I have ds to hold the data segment. Data is a directive. Remember we said directives, we had instructions, directives. The directives are not part of the instruction set, but are recognized by the CPU or processor. Data saying here's my data part, data section. Code saying here's my code, and I'm starting main process, integer main. Think of it. You write your code here, then you have exit, return 0, exit to the operating system, return 0 in C, C++, and we have main end process. We have a process is gonna end it, and then end main. This is usually how it should look like, and I don't want to mess with the template. I want to leave it so we can use it each time. So let's start, and I'm gonna write it from scratch. Include Irvine32.inc. Do you think it's gonna give an error on the capital small letter? Let's see. I don't want a .data. I'm not gonna have a .data part, so we're gonna comment that part, and then I'm gonna have the code, my code main process, and let's do the exit here, and main end process, and end main. And you can see what this is capital. Let's see if it makes a difference. Exit is what? A directive, or is it a micro, or what? You can see in other codes, exit 0, invoke exit process 0, invoke exit process 0. So this replaced it. So what did we say there? Is, remember, text substitution. So let's see now. Main process, what do I want to do here? I want to move to AX, and I want to move to a FFH. And remember, hexadecimal, when I use hexadecimal numbers and I have a letter which is the F as my first number, I have to put a 0. And let's leave it and see what types of errors it gives me. Now move. Now I'm gonna do the call dump register, and this is gonna print me. This is a function procedure. Now a procedure, I'm using the one here. If I didn't have the KIP Irvine library, oh, you're gonna have a hard time doing it. So if I was, this is why I told you I'm not gonna do all the programs as this is considered. If you want to do it as low level assembly, really advanced, because I'm gonna have to print every register by itself. So now we're gonna say more add, let's add, or let's increment a X. And look, what did I, both of those are capital, this is small. I'm doing that on purpose. Here I put capital. Let's see if it gives me errors on that. Increment comes with 1 operand. Move comes with 2 operands. And I can move a constant to a register. So this is going to say what? I'm basically here saying AX equals FFH. H meaning hexadecimal. That's the only thing. And now I'm calling. Call is to call a function. Calling the dump register function, which prints all of the registers. It's a really nice feature that you can. There's no semicolons to end any instructions. Nothing to worry about. Now here I incremented it, and now let's do another move to EAX, and I want to move 0 to it. Okay, let's do another here called dump register also. I'm gonna try to take my time at the beginning. I know I always say I'm gonna be fast, but I want you to understand everything, guys. So I'm gonna print here another call dump register, so we know each step what we're doing. We can do that by debugging, and I'm gonna show you how to do it on the kernel also. Register, and now what do we have? Okay, and now I'm doing AX. If I added 1 to AX, I don't need this one. Let's do this, because I don't need it. It's gonna be, and if FH also the same number. And now I'm gonna increment what? EAX. I want to show you the difference between, and this takes 1 operand. And here what did I do? I added 1 to AX. Whatever AX is, we did AX plus 1, and we saved it in AX, printed all the registers. Here again I said AX equals what? FFH. And now what did we increment here? Those are comments just for you guys. I'm putting it EAX, not AX. So I'm saying EAX equals EAX plus 1, and this is also a comment. and let's okay. So we took move, increment, and we can say here I just wanna I show you how to use the add command. Increment is the same as the add 1. I'm adding 1 to the accumulator. Let's close the template. No. Here, and remember, you set the external tools, those, and I showed you on the previous video. You go here and you set them from here. Tools, add those. I wrote them, and I showed you how to do it in the previous video. So now I'm saying tools, external tools, and I'm going to do build Masm 32. Masm error cannot open file.asm. Why can it? Why do you think? I didn't save it. It's document 2. It's not saved yet. It doesn't have a place. Where do I need to save it? I'll save it in the same place here, and let's say our first video program. .asm .assembly, and then save. And now we go tool. I think I left an error. We're gonna see where the error is. First dot error line 10, undefined symbol. Didn't know those. Why didn't know what is FF? And remember we said we put what? Zeros. A 0. If I have a hexadecimal number as a letter, I have to put a 0 before it. So I put a 0 here. If I had a hexadecimal number that is a 987, I don't put a 0 before it. And here's the second error. And did I close it? It's important to close that one. Close that window before going and running. Voila, here, no errors. Everything is good. Close it. And now I'm gonna run it, but I need a column register here also. But I'm gonna show you. I have here, what am I saying? Here, move AX 0 FF. Where's here's the EAX column register. This is the first one, column register. It's printing what? It's showing us all the registers. Let's put it here, and let's put it this way. This is showing the registers EAX, EBX, ECX, EDX. So why does EBX have values in it? It has garbage. It has. It's not necessarily all of them to be zeros, but it's important for what? The ECX, which is a counter register, to be 0. Those that I'm not using, I can set it as 0, but the most important for us, I set those as FF. AX. This is what? This is how many? But this is what? FF. Oh, it took it 0 0. This is AX. Sorry guys, my bad. 0 0. I can add here 0 0 for A, but it took the 0. Took it as 2 bytes operand. So this is AX 0 0 FF. And now what do? I increment AX. What happened? Took the one here. FF plus 1, what is it gonna give me? 0 0 and 1 overflow. but I have an overflow on those. Those are the registers, the carry. This gave me a 0. Why? Because I got a result of 0 in one of the registers. Now again, what am I doing? AX, I did it again as FF0, so it took this 0 0 FF, and now I added 1, but I didn't see what happened here. But I need to do a call dumb register, and see, capital, capital, small. It didn't make a difference. Yeah, I need to close that window before I start running it again. So now tools, file, save, tools, external build, ASM, awesome, no errors, tools, and run ASM program. And here's our program. Move AX 1 FF, and here 1. I'm gonna run it again. In the next video, I wanted to show you a point, but I did it in the wrong way. I should have had AL, or made AX added more F's on it. I'll show you in the next video what I meant, but this is good. Showed you what happened. I wanted to do one of those flags to set it as 1 also. This is mainly assembly programming, Masm, using the KIP Irvine. Please, if you have any questions, let me know. And we're gonna do a lot of this before we go into the others. Whatever I think we need any of the other programming languages, next class we might take one of them, the assembly also, maybe 2. I'm thinking classes, man. I miss. Anyway guys, this is it for this video. I'll see you next video.